Our project was to find the kinetic coefficient of friction between two objects. In our case, we measured the coefficient of friction between multiple spheres made of different materials and a duct-taped Hot Wheels track. So the way our system should work starts at the coupled tank where the height of the water is controlled by the VI. This is possible because the pressure transducer gives us a pressure reading which we can use to calculate the height of the water in the tank using this equation, and knowing the density of the fluid we are using, which was water. After setting the height of the ramp, we then have the ball roll down using the ramp, which we try to make as linear as possible. The importance of having a linear track will later be explained. Then the ball will pass through the third component of our system, the speedometer. When the ball passes the first laser and diode, it will start a timer, and this timer will stop once the ball passes the second laser and diode. So having measured the time between the two lasers and knowing the distance between said lasers, which are in a fixed position, we will be able to know the velocity of the ball. Using what we know and what we measured for, we can use the conservation of energy equation to find the coefficient of kinetic friction.
In our system, we use two different sensors, one of which includes a photodiode. A photodiode works by converting light which hits the diode into an electrical current that could be used for calculation. The electrical current is produced when a photon hits the diode, resulting in an electron hole and a free electron. This is also known as a photoelectric effect. The electron moves towards the cathode and the electron hole moves towards the anode, resulting in a current. More light equals a higher current. The second sensor we used was a pressure transducer. Pressure transducer works similar to a strain gauge. When pressure is applied to the pressure transducer, it converts it into an electrical signal. Pressure transducers are made up of two components, a diaphragm and a sensing element. Sensing element is usually electrical. The more the diaphragm bends, the higher the electrical signal will be. With this signal, you'll be able to do different calculations.
So the way this whole project works is that we have a power supply that powers the DAC, which has the circuit that controls the intensity of the lights of the lasers due to the room's light intensity, and this circuit is connected to the DAC, which digitizes those analogs coming from the diodes and the transducer as well, and digitize them and sends them to the lab view. The energy difference between those two is basically the frictional energy, and using equations on LabVIEW, we can calculate the coefficient of friction of different objects and different materials.
For our project, there are 6 different sources of error and limitations. The first one being different surfaces. For our project, the ball travels along a track made up of duct tape, plastic, and wood, meaning the coefficient of friction is going to be between the ball and 3 different surfaces, all present in different lengths. Number 2, we have measurement of ball travel distance. For this measurement, we have used a meter stick and found an error of 1 millimeter, as this is the smallest increment on our measurement tool. Number 3, margin of error for height. Due to our oscillating height mechanism, we have established through observation an error of approximately 1 centimeter from our set height. Number 4, accuracy of photodiodes. These photodiodes are stated to be high accuracy and have a maximum wavelength of 880 nanometers. Number 5, accuracy of transducer. The transducer has error due to human calibration, a maximum response time of 1 millisecond, and a sensitivity of 45 millivolts per psi.
As we found, slow speeds often broke our velocity detector by allowing it to hold on to values from the previous test. Our goal was to implement some sort of restart to stop and zero our timers. Now, when the timer is running and the button is not being pressed, a value of 1 is being added to the shift register for every iteration of the while loop. While the timer is not running, no values are being added to the shift register. Additionally, at any time a button can be pressed to zero the shift registers and the photodiode values, allowing us to effectively reset our timers. Finally, the current shift register value times the reciprocal of the sample rate will give us a timer reading in seconds. We have created 2 identical setups, one for each photodiode, to have them run individually.
So as we are getting the coefficient of friction from our project, these values can be used by the tire manufacturing companies to customize the materials which they are using for their tires, and also these values can be used by the spare parts manufacturing companies also in making parts like brake pads or rotor and customize them according to the road conditions and the amount of friction which can be experienced on certain surfaces or tracks.